everyone. Thank you for joining today. My name is Shannon Burth, and in this video, I'll be using SPSS to demonstrate how to compare means using an independent t-test. I'll be using the simulated data set that accompanies the second edition of the textbook, Quantitative Research Methods in Communication, The Power of Numbers for Social Justice. Thanks for joining. As you learned in Chapter 9, many statistical tests are available to test the differences between or among groups. Before we begin demonstrating some bivariate tests of differences, we should briefly explain degrees of freedom. Many, but not all, statistical tests require the researcher to report degrees of freedom alongside the test result. Degrees of freedom are labeled lowercase d, lowercase f, italicized. Degrees of freedom are the number of values that are free to vary when calculating a statistic. So imagine you have four numbers. They all add up to 22. The first three are 12, 3, and 5. The last one has to be 2. It can't vary because that's the math. That's how it works. So the degrees of freedom in that test is 3. 3 numbers can vary, and that last one has to be fixed. It's standard practice to report degrees of freedom alongside many of the statistical tests that we cover in this video series. And in this video, we'll report degrees of freedom for the independent t-test. As we discussed in Chapter 9, an independent t-test is a common statistical test used to determine whether the means of a variable of interest are different for one group of participants compared to another group of participants. So we're comparing groups here, 2 groups specifically for an independent t-test. We can run this in SPSS. And to do so, we'll select Analyze, Compare Means and Proportions, and then we'll select Independent Sample t-test from the pull-down menu. So looking at our variable list on the left, we're going to need to find our grouping variable, which is going to go right here at the bottom of the dialog box. And that's what's going to separate our participants into 2 groups so that we can compare them. Today, we want to use a variable that's going to separate our sample into 2 groups, the 2 groups being those who did and those who did not regularly play video games in the last 1 to 2 years. So that means our grouping variable is going to be VG yes, no. That's what it's titled. I'm going to sort this alphabetically and then also by variable name. That way I can easily find the VG yes, no. There it is, grouping variable. Send it over to grouping variable. So typically this will be 1 and 2. And SPSS actually already defines the groups for us, 1 and 2, but that's not always the case. In this case, yes equals 1, 2 equals no. But if you think back to our last video, we were looking at political ideology, so we could compare the 1s and 7s being the liberals and the conservative participants. Or if you remember, we also recoded that at one point to put it from a scale from 1 to 3. So we could compare the 1s and 3s. But typically it's 1 and 2. SPSS has a good idea that it's going to be 1 and 2, so that's how they autofill it. Works for our case now at 2 as well. So next we want to look for the variable that's going to be our dependent measure. I'm going to put it back to have the item labels because I'm looking for a specific item that reads, I think a young man should try to be physically tough even if he's not big. This is a single item from a larger scale in our sample data set. And what we want to do here is we want to be able to run a t-test on that dependent variable to explore whether or not regular video game users and non-regular video game users differed in their responses to that item or their agreement with that item. I could also select several items here if I wanted to. And in that case, what would happen is SPSS would run a series of independent sample t-tests. It wouldn't run them all in one analysis, but instead it would run one for every single item, and we could see how it looks for every single item. But today we're just going to look for one, and I see it right here. I think a young man should try to be tough, even if he's not big. Put it over in our test variable box, and then SPSS gives us an option to click OK. So using our grouping variable that compares those that regularly play video games and those that don't regularly play video games, and our dependent variable, our dependent item that we're looking at here, I think a young man should try to be physically tough, even if he's not big, we can test the hypothesis. Those who regularly play video games will be more likely to think that young men should try to be tough compared to those who do not regularly play video games. In our output here, we can start exploring that relationship between those 2 groups and our dependent variable. First thing we see here is a mean and standard deviation for both the group that plays video games regularly and the group that does not play video games regularly. We also have our N here, which is our sample size, which tells us how many people are in each group that we compared. Just eyeballing it here, if we compare the means, just looking at the two of them, they don't look that different. They're pretty similar to each other. However, if we want to answer a hypothesis or research question more persuasively, we can look at this second box that comes out in our output. So it's important to first know that as independent sample, t-test assumes that the variances of the two groups in question are equal, but the test can correct for the possibility if they're not. And when I say variance, variance is similar to standard deviation in that it has to do with how the values are spread out in the data. The difference between standard deviation and variance is actually in how it's calculated. Variance is calculated from squaring the standard deviation. So anyways, we see that SPSS actually gives us an output for if the equal variances are assumed and the equal variance is not assumed. We see two T results, 2 degrees of freedom, 2 significant levels. So in order to determine which set of numbers we're going to be using, we want to look at Levene's test for equality of variance. It's going to be right in here. If the significant level of this test is less than 0.05, we can assume that the variances of our two groups are unequal, and we can interpret the lower line of the statistics right here. If the significance level for Levene's test is greater than 0.05, we can assume the variances are equal, and we'll read and report this upper line here. In our case, we can look at the significant level, 0.791, which is greater than 0.05. So we can assume equal variances between the two groups, meaning an approximately equal spread of values in both groups. So this means we can read the T results from the top line of the output here. So to make sense of this output, there's a couple important pieces that we're going to want to be looking for. The first is the T statistic, the degrees of freedom, and our significance level. This is going to be our p-value. The degrees of freedom in an independent sample t-test is by taking the n, the sample size, and subtracting 1. We have 411 here. If we had gone with the equal variances not assumed, it's calculated a bit differently, but for today, we'll stick with this top number, and we know that it's n minus 1. When we write degrees of freedom up, we'll put it next to the t, the italicized t statistic, and we'll put it in parentheses. So as I mentioned before, we're going to be using the top line of the output box for writing up our results, and that would be written italicized lowercase t, parentheses, 411 for our degrees of freedom, close the parentheses, equals 0.541. We'll round that and it'll end up being 0.54. This shows that there's no significant difference between the two groups and their agreement with the statement that young boys should try to be tough when comparing regular video game players and non-regular video game players. Therefore, we can say our hypothesis is not supported. For both independent and dependent t-tests, it's kind of difficult to interpret the t result, except to say that generally the bigger t statistic, the more likely you will have statistically significant results. This makes sense because the larger the difference between the two groups, the less likely it would be to see a difference between groups in the sample that is not also present in the larger population. So that's all I have for you today. Thanks for joining us, and be sure to come back next time for our next video in the series. We're going to be comparing means again, comparing more groups, but this time it'll be an ANOVA, or an analysis of variance. Thank you.